Dear students, greetings to all. In this module, we will carry out the revision of chapter 1, that is matter in our surroundings. So we know that whatever is present around us is referred to as matter. So matter can be defined as anything which has mass, okay, which occupies space. It can be felt, okay, it can be felt and it offers a resistance, is what is referred to as matter. Now we know that matter can be classified on the basis of, so there is the physical classification of matter and there is also the chemical classification of matter. Now talking about the physical classification of matter, matter can be classified on its physical basis into three different types, that is solid, we've got the next, that is liquid, and later to it there is the gaseous form. If we talk about the solids, they've got fixed definite shape, definite volume, the kinetic energy is least, they've got very strong intermolecular force of attraction between the particles. Liquid exhibit intermediate characteristics, but they are fluid in nature. Gases, their kinetic energy is maximum, they can freely move because there is no interparticle force or very little or minimum interparticle force of attraction between the particles. They can diffuse very easily from one place to the other and they are most compressible. We know the examples of gases like the CNG and LPG, which are formed by compression. So the change, so here when we talk about the gases, so compressed natural gas and liquefied petroleum gas, through this we come to know that the gases, they are easily compressible in nature. Talking about the interconversion of states of matter, that means we can convert solid into liquid, liquid into the gaseous form, and it can be done vice versa. That means the gaseous form can be converted into liquid and the liquid can again be converted into solid. Now this interconversion among the three states of matter is possible by bringing about changes in temperature and pressure. So if we'll increase the temperature, solid will change into liquid and then gas. And if we decrease the temperature and increase the pressure, gases will change into liquid and then finally solid. Now we need to understand it through a triangular representation, schematic representation, that what is this process of solid getting converted into liquid referred to as, and this liquid getting converted into gaseous form referred to as. So solid can get converted into liquid, liquid can get converted into gas, gas back into solid. Now this process of conversion of solid into liquid is what is referred to as fusion or melting. Conversion of liquid into gas, that is what is referred to as vaporization. So that's the process of vaporization. Here when we talk about the gases getting converted into solid or the solid getting converted into gases, it's one and the same. So it will be referred to as sublimation. So that means the process where gases get converted into solid or solid into gases without going into liquid state is referred to as sublimation. Now gases can get converted into liquid. So when gases they get converted into liquid, the process is referred to as condensation. So it's called as condensation. Now when this liquid gets converted into solid, so when the liquid gets converted into solid, the process is referred to as, it's called freezing, or it is also referred to as solidification. So thus we observe that the states of matter, they are interchangeable in nature. Now let us talk about the important criteria, important feature like evaporation and boiling. Now what do you understand by the term evaporation, the phenomenon of evaporation? That means here the liquid is getting converted into vapor, but then at a temperature lower than its boiling point. Boiling obviously will take place, if it is of water, it will take place at its fixed point, that is 100 degree centigrade. The melting point is 0 degree centigrade. Now the factors which affect evaporation are, that is the wind speed, surface area, humidity and the temperature. So what is the difference between boiling and evaporation? Now when we talk about evaporation, that is a surface phenomenon, whereas boiling is bulk. Evaporation takes place at a faster rate, slower rate, and boiling, it is a fast process. When we talk about evaporation, so it uses natural light, whereas for boiling we take artificial light. Now when we talk about evaporation, it takes place at a temperature lower than the boiling point, whereas boiling takes place at a fixed temperature. So here we understood that there are differences between evaporation and boiling, where we can say that we can understand evaporation by taking the examples of acetone drying very quickly when we place it on our palm, the example of desert coolers pumping the cool air, the earthen pots which keep the water cool in winters, in summers, and the process of wearing cotton clothes in summer, which lead to cooling. So evaporation, that's the other difference, that evaporation causes cooling, whereas boiling does not lead to cooling. So in this module, we tried to revise this particular chapter, that is matter in our surroundings. Hopefully, you must have garnered the basic and important concepts related to the chapter very thoroughly. Thank you.